Hello. So today the average link distance to compute distance between clusters will be discussed as an example. We first take a recap of the definition, which is that the average link distance between clusters is the average distance between an element in one cluster and an element in the other. So if we are talking about the Ci and Cj cluster, so the distance computed as the average link distance is found in this manner. You take the summation over all the points of Ci and all the points of Cj, take their distances and divide by the number of pairs, which you get Ni into Nj. We also go through an example from our previous video. We have 5 points distributed into 2 clusters. These are the points, and we have the dissimilarity or distance matrix. So what is the average link distance between the clusters C1 and C2? So we can realize that what do we have to do for this? We have to find the distances between points in cluster 1, which is the point number 1 and 2, and points in cluster 2, which are 3, 4, 5. So that is what we have done. We have taken D1, 3, 1 from C1 and 3 from C2, D2, 3, 2 from C1, 3 from C2, D1, 4. Similarly, 1 is from C1 and 4 is from C2 and so on. And total number of pairs is 6, 2 cross 3. So this value which we get is 3.55. So this is the average link distance between the clusters C1 and C2 as according to the values given to us. Now the agglomerative hierarchical clustering method described in terms of average link distance. We are quickly going through it. That for the merging process, it finds the clusters CICJ from the entire set of clusters which are closest to each other according to average link distance. It combines these two, Ci and Cj are combined to get Cij. Then it merges, updates the clustering until termination criteria. Now we take an example where the distance matrix is given for the 5 points. See, here we are taking a scenario where the data points are not given to us, only the distances. These distances might have been computed in any manner. So from this point on, how do we go forward? So we take the initial clustering is as usual, each point in its own cluster, and this is the corresponding dendrogram. 5 branches. So in step 1, we find out the shortest distance, which is this A to B, the value 1 out of the whole matrix. We could have taken CD, but it is normally taken as the lexicographically shorter, a smaller value. That is a dictionary ordering. So we merge AB and recompute the distance matrix. So this is what we get. The distance matrix computed after this merging. Now, see this value AB to C. How have we got it? We take the distance from A to C, distance from A to C, okay, which is this value 3, and the distance from B to C, which also incidentally is 3, and we take the average, which is 3 again. Similarly, from AB to D, A to D is 2, B to D is 2. See, both these values are 2. So we again get an average of 2. However, in the case of AB to E, A to E is 4 and B to E is 3. So we get an average value of 3.5. So this is how the distances are computed, as also seen in the example in the previous slide. So this is our distance matrix, and the dendrogram, see AB has been combined. So this is what we see here. At this point, AB are combined. So we have how many clusters? 1, 2, 3, 4. 1, 2, 3, 4. At this point, we had 1, 2, 3, 4, 5. Right? So next we go to the, we continue the example. So distance matrix after step 1. So now what is the shortest distance? We can see this 1, C to D. So we merge them and recompute the distance matrix and also make the dendrogram. So the distance matrix computations proceed as before. AB to CD would be taken as the average of AB to C and AB to D, which we can see here. AB to C is 3, AB to D is 2, so the average is 2.5. And AB to E we already have it. Similarly, CD to E is the average of C to E and D to E. 3 plus 5 by 2 is 4. So this is what we get, 3 clusters, and this is the distance matrix. Next, now we examine this matrix, which is the smallest value, which is 2.5. It is the distance between the cluster AB and cluster CD. Okay, so that is what we would do now. We merge them, that is AB and CD are merged, and recompute the distance matrix. This is what we get. Distance matrix now has a single value because there are only 2 clusters remaining. See, we have just 2 branches, 1 and 2. This the first one has A, B, C, D in it, and the second one has E alone. So now the final steps we can go through quickly, because we left it at a step where there were 2 clusters and it would be merged to 1 cluster. So we started all the steps of dendrogram building we'll see in this final slide. So we started with 5 clusters. Then we merged AB to get 4 clusters. Further we merge CD. See, we make this level because that is the joining was after this one. So first AB, then CD to get 3 clusters, 1, 2, 3 branches. Then 2 clusters because here CD also has been joined. Finally, the final dendrogram comes out this way, where we have only 1 cluster remaining, which is the combination of all the points put together. So this was the first stage, merging, agglomeration, AB. Second was CD. Third was ABCD together at this point to get 2 clusters, and finally we get ABCD with E to get 1 cluster. So this is how we would do the clustering given distance matrix for 5 points. Given the data points for 5 points also we can proceed. We compute the distance matrix and then move on as we did in this example. Here, of course, we started with the distance matrix from that point and we computed the average link distances. So I hope this method is now clear to you, how to use the average link distance method for computation of distances between clusters and do the agglomerative clustering. So thank you. Thanks for watching.